Hey guys, we're back, and today's lesson is Unit 4, Lesson 3. We're doing a second day of Piecewise defined functions. So today, just to regroup and practice, we're going to just start by graphing the following piecewise functions. So we have f of x equals x squared minus 3 when x is less than 1, 0 when x is equal to 1, and x plus 2 when x is greater than 1. When we go to graph these, remember from yesterday, we want to set up a table for each piece. There's 3 pieces here. So we're going to have 3 tables. And when x is less than 1, so we could take maybe 0 and 1, we're plugging into x squared minus 3. When x is 1, y is 0. And when x is greater than 1, so we'll take 1 and 2, we're using the function x plus 2. And all we're going to do is set up each table and then plot it. Starting with the first piece, that line, when x is less than 1, that parabola. 0 squared minus 3 is negative 3. 1 squared minus 3 is negative 2. So if I go to graph this piece, remember this is when x is less than 1, 0 is at negative 3. And when x is 1, my y value is negative 2, and it's an open circle. And now this is a little weird. So we're not quite sure what to do. I know it's a parabola. It's a parabola shifted down 3 units. You might be able to visualize this. But if you needed to, take another value. Plug in negative 2, and you would have the point 1 on the curve. Then you'd really see that parabola. So if you need more than 2 points, that's fine. The ordered pair, this is just a point. When x is 1, y is 0. So that's the point 1, 0. And I just want to remind you, we plot this as an open circle because of that inequality sign. And when x is greater than 1, we're going to be sketching that portion of the graph. It's going to look like a line. 1 plus 2 is 3. 2 plus 2 is 4. 1, 3. That goes on as an open circle because of our inequality sign here. 2, 4. And there's my line. So that's the basically what that graph looks like. I could ask you different types of questions about it. We went through that yesterday. Today, I just want to remind us how to actually make the graph. The next picture, 2 minus x from negative 3 less than or equal to x less than 1, and the square root of x when x is greater than 1. 2 pieces, 2 tables. As you get better at this, you'll stop making the tables, but in the beginning, I highly suggest setting up your tables. 2 minus x, square root of x. Negative 3 and 1. And even if you want to help you to remind yourself, you could do a little circle here. That's going to go on as closed, and the 1 will go on as open. That helps you, if it helps you with the graphing. Negative 3, 2 minus negative 3 is 5. 2 minus 1 is 1. Negative 3, 5. That was a closed circle again. And 1, 1. And that was our open circle. So we have this line. And the next piece is a square root function. We're starting at 1. We're plotting as an open circle. And we can pick another number on that bigger than 1. I would pick 4 because 4 is going to work out as a nice point. Radical 1, square root of 1 is 1. Square root of 4 is 2. 1, 1. That circle is going to remain open. 4, 2. And we know it's going to follow that shape of a square root function. Something I could ask you, is this continuous? The answer would be no. So those are just things that we have to remember that we already know. In this next function, I have y equals negative x when x is less than or equal to 0, and x when x is greater than 0. So we have 2 tables. I know some of you can picture this in your head, and that's okay if you can do it, but it doesn't hurt. Negative 1 and 0, negative x, and x when x is greater than 0, when x is negative 1, so we have 1. And the absolute value, I mean, the negative 0 is just 0. Negative 1, 1. And this one's going to be a closed circle. And remember, even though we just drew those two lines, we're actually, those 2 points, it's actually going to extend forever. When I plug in 0, I get 0. When I plug in 1, I get 1. That's our y equals x line. Okay. And basically, when you're looking at this, what do you see? Okay. This is the same graph we get when we sketch the graph up in absolute value. So we can really rewrite an absolute value function as a piecewise function. And that's what we're going to talk about today, okay? And we use this in calculus often. We have to use this rationale. So to rewrite an absolute value function as a piecewise defined function, or basically without absolute value signs, okay? Here's our function notation. And this is what our absolute values looks like without absolute value signs. So it's a if x is greater than or equal to 0, and negative a if x is less than 0. Okay. I want you to kind of not worry about that too much. Okay. We're going to focus on how to approach each particular function. So basically the steps is we're going to find a new vertex, because think about it. That's where we're going to switch from one line to the other. And to do that, we set inside the absolute value brackets equal to 0. Then we're going to make a number line, or basically what we call a sign chart. Okay, we're going to test. We're going to test each interval. And then we're going to simplify if we have to. Then the next step, and this is critical, we're going to rewrite with absolute value signs. When the function is positive, all you're going to do is drop the sign. And when the function is negative, we're going to negate what's inside. Okay, and I will talk about this in just 1 second. So we're going to start with this function. F of x equals the absolute value of 2x plus 4. Okay, you don't even need to really know what it looks like to do this problem. Okay? The first thing we do is we find the vertex. Okay, to find the vertex, or where it shifts from one line to the other, we just set inside the absolute value equal to 0 and solve. So this is going to change functions when x is negative 2. That's our vertex, so to speak. We're going to put that number on a number line. Test each side. So if I plug in a number less than negative 2, what do we get in our absolute value sign? So let's think. If I plug in negative 3, I get negative 6 plus 4 is negative. I get negative 2, but basically all I want to think is this number positive or negative? Now think about it. Let's say you have negative 2. What's the absolute value of negative 2? Well, it's 2. So what did you do when you thought about what the value was when you took away the signs? You negated. So we negate. When we're dropping the signs, we negate inside. Move on to the other side. And we'll use 0. When I plug in 0, I have a positive value inside, right? 0 plus 4 is 4. What's the absolute value of 4? Plain old 4. So you don't do anything. You leave the function alone. So if we were graphing this, we're going to use the rule negative 2x minus 4 for x values that are less than negative 2. And we're going to use y equals 2x plus 4 for values that are greater. So we're going to write this. Negative 2x minus 4 when x is less than negative 2. and 2x plus 4 when x is greater than negative 2. And now the only number we don't have going someplace is negative 2 itself. And you can attach negative 2 to either function. It doesn't really matter this year. So we just have to give negative 2 a place to go. So we'll just plug it in the top one for this example. Okay, it really does that doesn't matter. Next year, we'll talk a little bit more about that, but this year, that's great. Let's look at another example. So I have the absolute value of 3x minus 2 plus 2. We're going to focus on where it changes rules first. So we just think about, don't worry about the plus 2 right now. We just think about inside the absolute value sign, because remember, the plus 2 is a vertical shift, really. It's not going to affect where it changes rules. So at x equals 3, that's when my function is going to change from one to the other. Now I plug a number in that's less than 3 and see what type of number we have inside our absolute value sign. So let's say I use 2. 6 minus 9 would be a negative number. To rewrite this without signs, okay, so when I go from the one side of the number line to the other, I'm going to negate what's inside. But now I have to attach on that plus 2 at the end. Okay, because that's how I'm going to finish my problem. So this becomes negative 3x plus 11. So if I was writing this function, I'll do it one step at a time this time. Negative 3x plus 11 when x is less than, we'll attach the 3, equal to 3. And we'll move on to the other side. If I take a number bigger than 3, I get a positive number just inside. We don't care about the outside yet, just inside. When I drop the signs, I don't have to do anything, but I have to remember to tack on that plus 2 at the end. 3x minus 7. If x is greater than 3. Your equal can only go in one or the other. Okay, so just be aware of that and be careful. This was a little bit trickier. This is a real advanced one here, but we're going to give it a shot. Okay. So now I have, in order to find out where it changes, I'm just going to set what's inside equal to 0. And to get my x plus 2 minus 1. So x is negative 2 and x is 1. Yuck. Negative 2 and 1. Now I have 3 intervals, so I have to pick a number in each interval. And think about this. We can test in our factored form. It's going to be a lot easier if we pick a number less than negative 2. So let's say we use negative 3. Think about the numbers you have. Okay, so I have negative 3 plus 2 is a negative factor. Negative 3 minus 1 is a negative factor. A negative times a negative gives me a positive inside my absolute value sign. So when I take away the signs in this section of the x-axis, I'm just using the original. Now I'm going to go in between. I'll take 0. And positive and a negative, I have a negative here. So in this interval, in this section, I have to negate what's inside. If I'm rewriting it without absolute value signs, I'm going to negate what's inside. And when x is greater than 1, we'll pick 2. I would have a positive times a positive. We would have a positive inside. So when I rewrite it without signs, I'm just going to write it how it appears in the absolute value. And now we just x squared plus x minus 2 when x is less than -2, negative x squared minus x plus 2. Now this is from the x values, -2 less than x less than 1. Okay, that's this in between section here. And then we plug into x squared plus x minus 2 for all x values greater than 1. Now I did not include my endpoints, and I have to think about it. My rule is going to change here, right? And here. So you just have to decide. When I have a quadratic like this, I usually just put it right in the middle there. Okay, you just have to find a place to plug in the -2 and the 1. Okay, it can only go on 1. And do I have, I have 2 more. Okay, so number 4. Number 4 is also a little tricky. Number 4, I have the absolute value of x plus 1 over x plus 1. So first off, I'm just going to find where it changes rules. So -1 is my kind of my vertex, so to speak. When I plug in a number less than -1, I only focus on the absolute value right now. What type of number would be in the absolute value sign? A negative. So if I was going to rewrite this function, right, without absolute value signs, it would be -x minus 1 over x plus 1. And this is hard to see, but if you factor out that negative, you actually wind up getting -1. So I'm writing this function, -1 when x is less than -1. Go to the other side, I plug in 0, I would get a positive. And again, when you're doing the testing, you're only thinking about the absolute value itself. Now we do the simplifying. When I drop my sign, it's just what it is. Rewrite it with the other part of the function now, and I would have 1. 1 when x is greater than -1. And now we just have to pick which rule to plug it into. I don't care. We can do the bottom one this time. So, you know, these are not terrible. I want to just kind of go up here for 1 second. Think about that absolute value function. This is a quadratic, and it's a quadratic that has x-intercepts at -2 and 1. So basically, the original parabola would be something like this. When we do the absolute value, what does an absolute value function do? It negates. So that would be the absolute value function. You're just going to keep everything positive. And that's, you know, something that's good to know for the future. And our last function here, -5x plus 15. I just wanted to go through this real quickly. Again, start by setting what's inside the absolute value sign equal to 0 to find where it changes rules. And for this particular case, it's going to be at 3. Plug in a number less than 3. How about 0? In this case, if I plug 0 into my absolute value, I would have a positive number inside the absolute value sign. So when I take away the signs, I don't do anything to the function. Plug in a number bigger than 3. If I plugged in if I plugged in 4, I would have a negative number inside. When I take away the signs, I have to negate what's inside. And now we just rewrite this as a piecewise function when x is less than 3 and 5x minus 15 for all x values greater than 3, and we'll put the equal sign there right now. Okay. So today we did talk a little bit, reviewed from yesterday about the graphs of the absolute value, about the piecewise function. But today our main focus was on rewriting an absolute value as a piecewise function. Okay. Thank you and see you tomorrow.